So if you think about changes in the genetic code, can you think of any changes that would be beneficial or helpful to organisms?
Almost all mutations are deleterious. Almost all of them do the organism absolutely no good. In fact, we have a devilishly hard time finding any mutations that do the organism any good whatsoever.
These organisms only really survive in the laboratory. No other fruit fly will mate with them. These are not promising avenues for macroevolution. They're in fact dead ends for evolution because these mutations cannot be passed on by ordinary reproduction. It's almost as if the fruit fly says, if you want me to exist at all, I better have 2 eyes, 6 legs, 2 wings, and so on. I better have more or less the normal form.
Modern Darwinists contend that there are some cases where mutations do promote evolution. Their chief example could be considered another icon of evolution: antibiotic-resistant bacteria.
Antibiotic resistance, in terms of natural selection, is an excellent example. And its use, I mean, it's one of the hallmark examples given in microevolution for support of Darwinian thought. However, I think in the last few years, it's got to be reinterpreted to a degree.
Laboratory research shows that when an antibiotic is applied to literally billions of bacteria cells in a petri dish, a few mutated cells that happen to be resistant to that drug remain. Those few cells can then give rise to a colony of resistant bacteria. The question is, how well does this mutant strain survive in the long run? This can be measured in what scientists call fitness cost. How well does this mutant bacteria survive when the drug is removed and it now must compete with the original parent bacteria?
These organisms are not able to grow with the fidelity, the robustness that the original parent did, and that's one of the things that we've been looking at. So you can take a culture of cells that are sensitive to the drug, plate them out on petri dishes that have the drug, but there's a single colony coming up that's resistant to the drug. One cell that gave rise to this colony was resistant to the drug out of 4 billion. If this is the parental strain, we now have a mutant, we grow them up separately, and then we put them in the same test tube without the drug. So now we've removed selection, and we can measure empirically the fitness cost in terms of how well the resistant organism can now compete with its parent.
The surprising result is that in a relatively short period of time, the resistant bacteria lose out in their competition with the parent. They can't reproduce as fast, and over a short time disappear.
Within 1 or 2 transfers of overnights, you can lose that population of resistant cells. And then after the 3rd transfer, The resistant isolate has been completely outcompeted by the parent. It turns out that the resistant strain has a defect in its information processing system. The cell's crippled, and there's a limit to how much change can occur. When the resistant strain comes into contact with a parental wild type in nature, the parental wild type will reestablish dominance in the population, resulting in no net evolutionary change. We're going backwards in terms of the fitness of these organisms, not forwards, is used as an example of evolution.
According to critics of Darwin's theory, finch beaks, four-winged fruit flies, and drug-resistant bacteria all raise problems for the neo-Darwinian claim that random mutations and natural selection drive the development of life. But there's another part of Darwin's theory that is also being challenged by some scientists. That's the claim that all living things are ultimately descended from a common ancestor. This claim underlies perhaps the biggest icon of evolution of all, the tree of life.
The classical Darwinian picture of the history of life is that of a tree, that these small incremental changes build up and they branch out, and so you start from very simple life and eventually you get everything that we have around us, from elephants to alligators to chimpanzees and everything in between.
Critics say that evidence used to support Darwin's tree of life is just as questionable as evidence used for the other icons of evolution. One major piece of evidence used to support the tree of life is homology.
There is the front flipper, a hand built on the same model as my own hand.
Biologists define homology as similarity in structure between different organisms.
Now this has the same design exactly as your arm. There's the upper
My
arm,
textbook
one bone.
would show the forelimb, a hand, and it would show a bat's wing and a whale's flipper, and say because they have similar structure, have similar bone pattern, that they must share a common ancestor.
And then the 5 very long fingers, just like yours.
The mere pattern of the bones doesn't tell you how it happened. You have to supply a mechanism to explain how it got that way. Well, Darwin's mechanism, as understood by modern Darwinists, was genetic. You inherited similar genes, and these genes made the bones grow the way they do. The problem is that the evidence doesn't fit that explanation.
According to modern Darwinism, if two structures are similar because of common ancestry, each structure should be produced by similar genes and go through a similar pattern of development in the embryo.